Okay, so let's start with the first application of your definite integral, which is the area of a plane region. So, so in integral calculus, so there will be different applications of your definite integrals. So we'll be starting with area, and then next will be volume. Then we have also surface area, and then we also have arc length, and then we also have liquid pressure, work, and so on and so forth. So in which all the applications is that we'll be using the definite integral concept that you have learned from the previous meeting. So magbalik-balik rin siyang concept. And I think this time you are allowed to use your calculator. Okay. Okay, so in the area of a plane region, so usually what we know from geometry is that you have a formula for the different shapes of the polygon. So such as the square. So for example, the area of the square is s squared, or the area of the rectangle is base times height, or the area of the circle is pi r squared, so on and so forth. So all of these formulas came from the integral calculus concept. So why these formulas become such? So in integral calculus, so for example, you have this x and y region, and then let's say you have an irregular shape figure in the positive region, quadrant 1. So in integral calculus, we need to solve this particular area, this irregular shape figure. And this can be achieved using your definite integral concept. So again, the formula from geometry, the s squared, the base times height, the pi r squared formulas, all of which came from this concept. Okay. So in the area of the plane region, so since we'll be solving areas in the x and y plane, so there will be areas above or below the x-axis. So it may look like this. So let's say you have a parabola, so above the x-axis, or it may also be above and below. So let's say you have this figure. You have a parabola here. So as you can see, above and below the x-axis. So it can also be across the y-axis. So such as this one. One is on the left of the x-axis, then the other one is on the right of the x-axis. And also there can be an area between two curves. So for example, you have this parabola here, then another parabola here. So the area between the two curves is the area that you're going to solve later. So I think the difficult part here is you need to know how to graph your equations, because if you don't know how to graph your equations, so I think that will be a very difficult part in solving the area. Okay, so sorry kay sa ero kay. Okay, so in solving the area, so we'll be using a vertical and horizontal strip. So why do we need to use vertical and horizontal strip? So if we go back to the concept of definite integral, so it is a summation of the strips. So if we go back to sigma notation, so the concept of which is, for example, this one is your triangle. So the method before is approximation. So you need to create different rectangles. So this one is what we call as the vertical strip. So if you want, excuse me. So if you want horizontal strip, so for example, this one is triangle. So it can also be in this manner, horizontal strip. Okay, so on and so forth up until you reach the end. So before you're able to use the definite integral, so that's why there's a problem in the midterm exam wherein you are made to solve the sigma notation, because before the integral symbol came, so everything was made through approximations and the sigma notation was used in those approximations. So that's why natoy murag sigma notation sa exam. But of course, it's not really relevant in this scenario, because what we'll be using throughout your applications is this definite integral concept, not the sigma notation anymore. But of course, if you are really geeky about the history of your definite integral, so you go back to sigma notation, and then the sigma notation developed to the definite integral. Okay, so we have two formulas. One is the vertical strip, so pertaining to this figure. And then the other one is the horizontal strip. So we have this formula. So the area is equal to the integral of y sub t minus y sub b. So y sub t is the function at the top. So again, if you're going to draw the vertical strip, so what equation is touching the top part? So that is your y sub t, y top. And the vertical strip touching the bottom, that's the y bottom, that's y sub b. So for example, it could be y is equal to x squared, then the bottom part could be y is equal to x minus 1. So that's the concept behind y sub t and y sub b. So that's why it's respect to x, it's respect to dx, because once you substitute your y function, so you have x values in your equation. So same goes for your horizontal strip. So looking at your horizontal strip, so despite that this one is dy, okay. So if horizontal strip na gaita, so what you're going to do is you have the x right, that's the x function touching the right portion of the horizontal strip, and then x left is the x function touching the left part of the horizontal strip. So for example, the x right is x equals y squared, and then the left part is x equals y cubed. So this becomes y squared minus y cubed. And notice that it's respect to y. And also the limits of integration are all in terms of y. So vertical strip, all should be in terms of x. So don't be confused with the y part here, because that's y equals to x something. Also on the horizontal strip, so everything should be in terms of y. So don't be confused with x sub r and x sub l, because those are just the definitions that you need to look out for. So the x function touching the right portion of the strip, and then the x function touching the left portion of the strip. Okay, so So to summarize, so vertical strip, all should be in terms of x. Horizontal strip, all should be in terms of y. Okay? So I think at this point, still don't appreciate the formula, but once we go to the example, so you'll be able to appreciate the concept behind the vertical strip and the horizontal strip. Okay, so we have 5 steps involved in the integration of plane areas. So again, the term here is integration of plane areas. So again, as per definition of your integral, so it's the sum, diba? So again, instead of um, determining the different dimensions of the rectangle, so that's why we represent it under one strip. Then we have A to B as your limits of integration, di ba? So imagine that if you're going to solve each value of the strip, so marag madugay ta, di ba? So that's why we have the integral, the definite integral to help us solve the area in a quick manner. Excuse. Okay, so there are 5 steps. So I think the first step is really the difficult part in the application of your definite integrals. So if you don't know how to sketch your equations, you don't know how to sketch a parabola, an ellipse, a hyperbola, an equation of a line, so I think that will be a very difficult part on you because most of the parts here is more on graphing the equations. So especially if you are now involved with 2 equations, so you need to determine the intersection of those equations. So if wala mo ana sa yung geometry, so you need to catch up with that particular topic. Okay, so slice it into thin pieces. So stripes or strips. So this is where the vertical strip and the horizontal strip will come into play. So you need to choose whether you're going to use the vertical strip or the horizontal strip. So again, if you're going to use this triangle, so you may use one vertical strip or you may use one horizontal strip. And the next is you need to label your piece. So you need to label what is x right, you need to label what is x left. You need to label y top, you need to label y bottom. Okay, so approximate the area of this typical piece, pretending that it is a rectangle. So as you noticed in the formula earlier, so let's try to write the vertical strip formula. So the area is equal to, so from x1 to x2, then y top minus y bottom dx. So notice that since we need to pretend it as a rectangle, diba? So the area of the rectangle is base times height. So if you're going to observe the rectangle here, so y top and y bottom is more likely the height of the rectangle. And then the width of your vertical strip, that's your differential width. That's your dx. So that's why it's the base. So notice that the formula is more likely the same as the area of the rectangle. That's base times height. So from y top to y bottom, that's the height. And then the differential width is the dx. So that's the same as your horizontal strip. So notice that from x left to x right, that's the length or that's the height. So that could be the base in the horizontal strip case. And then the height is this differential value of your y because we don't know the exact width. So that's the differential y and this becomes the height. So also notice that in the horizontal strip, it's the same concept as getting the area of the rectangle. Okay, so add up the approximations to the areas of the pieces. So in adding up, so that's why we have this formula because we'll be adding up the rectangular pieces through your definite integral. All right. So let's go to the first problem so that we can appreciate the concept. So find the area of the region bounded by the line y equals 3x and then the curve y equals x squared. So again, the difficult part here is graphing your equations. So let's try to graph this manually. Okay, so starting off with your y equals to 3x. So sa may now ana. So y is equal to 3x is linear, di ba? So this one is a line. And then this one is second degree. Then the other one is first degree. So this one is a parabola. So this one is just first degree. That's why it's a line. So in graphing the line, so if di mo kibawa mo graph sa line, so medyo lisod siya, di ba? So how about your y equals x squared, ba? Okay, so the shortcut for this one is we need to get the intersection of your line and your parabola. But if you don't want to do the shortcut, so what you need to do first is you're going to graph first the parabola and then graph the line afterwards. Okay, so if so starting with the parabola, so we need to create a table. So this will be the x and then this will be the y. So the equation is y equals x squared. Excuse. Okay, so if your value is 1, so let's say 3. So if the value of x is 3, so y is equal to 9, di ba? Then 2, 4, and then so 0, 0. So if x is equals negative 1, we have positive 1. Then negative 2 is 4. Then negative 3 is 9. Okay, so notice that we have 0, 0. So that will be the first point. So let's say this is 1 and 1, then 2 and 4. So let's say this is 9. So this is the positive portion. So the negative portion is just the mirror image of your parabola. Pati man ang drawing. Sige lang. So bale mo dyan siya ang lisod na part. So you need to graph your equations manually. So of course, there's always Desmos, but it's best that you learn how to graph your equations manually. Okay, so let's say, excuse. Okay, so the parabola is now done. So we now proceed with the the equation of the line. So let's use another color. Okay, so if x is 1, so y is 3. So if, excuse me. Okay, murag nakuha na kong tunlanda. So if x is 2, so your y value is 6. And then if x is 3, so your y function is, so let's try to reverse it and the same siya as the left table. So 3, 2, 1, and then you have 9. So 3 times 3 is 9, 2 times 3 is 6, 3 times 1 is 3. So let's say if x is 0, so y is also 0. So this one is the same point here. And then 2, 6, 4, 5, 6. And then 1, 3. And then 0. So this is the equation of the line. Okay. So since we are now done with the graphing portion, so we need to determine the area that we need to solve. So as you can see, the problem is stating that we need to find the area of the region bounded by the line y equals 3x and the curve y equals x squared. So the area that we need to determine is this region. Ini siya nga portion dire. Okay, so notice that their points of intersection is 3, 9, and then 0, 0. So these points of intersection will be important later in determining the limits of integration. Okay, so So another technique here is if you're going to do this in a quick manner, if you don't want to put tables, because I think there's a limitation in this technique. So, so another effective technique is for you to get the intersection by equating the two equations. So we have y equals to 3x and then y is equal to x squared. So equating the two equations, so incorporating the first equation in the second equation. So you now have 3x is equal to x squared, diba? And then you have x squared minus 3x is equal to 0. And then factoring out x, so you have x minus 3 is equal to 0. Okay, so notice that we can now simplify this one. So the first x is at 0, the second x is at 3. So now you have two values of x's. So you now plug it in either of the two equations to get the counterpart of the y component. So at x equals 0, so y is also 0. So the first point of intersection is at 0, 0. And then at x equals 3, so that will be y equals 3 times 3. So that is 9. So the second point of intersection is at 3 and 9. So notice that it's the same here. 0, 0, and then 3 and 9. So if you want to use this technique, so you need to know um, dapat ma-imagine ninyo the way your graph is going, di ba? So for example, this one. So if you're going to look at this one in the first glance, so you need to know that it's opening upwards, di ba? And then this one is a positive line which is inclining to the right for you to be able to use the shortcut in an effective manner. So if dili gani, so I think that will be a difficult part because even though you have the points of intersection, so you won't be able to imagine what the area looks like because wala pa ninyo na generate ang graph. And during the exam, so the graph will also be credited in the solution. So if you don't have any graph in your solution, so I cannot give you the full credit of your solution because the graph is a major part in getting the area. Okay, so next is we're going to choose what we're going to use, a vertical strip or a horizontal strip. So let's try to use both, but let's solve first using the vertical strip. So draw a vertical strip first. Okay, so take note that in choosing a vertical strip, it should be consistent with any portion you're going to place your vertical strip. So what do I mean by this is that if ever I place my vertical strip at the bottom or at the top, the y top and the y bottom functions will be the same, diba? So it won't change or it won't alter in whatever position we're going to place the vertical strip. So again, what do I mean by this is that the y top, so for example, the y top here is the blue line. That's y equals to 3x. And then the bottom part here is the red one. That's y equals to x squared. So again, what do I mean by your vertical strip being consistent? So if I place my vertical strip here, the top portion is still y equals to 3x. The bottom part is also y equals x squared still. So the same as if I place it at the top, so y top is still y equals 3x. So the top portion is still touching the blue portion. Then the bottom portion is still touching the red graph. That's the parabola. Okay, so as you can see, it's consistent, diba? Okay, so using the vertical strip, so that's the formula is so from x1 to x2. So y top minus y bottom dx. So again, y top is the equation touching the top portion of your vertical strip. That's y is equal to 3x. And then y bottom is the equation touching the bottom of the strip. So the y function touching the bottom of the strip. So we now have integral of, so y top is 3x, and then y bottom is x squared, and then dx. Okay, so next is your limits of integration. So since we are using the x term here, so we need to set our limits of integration in the x-axis as well. So that's where the points of intersection is important. So we have 0 here, 0, and then 3, and then 3. So same goes here in the shortcut. So the x parameters is from 0 to 3. The points of intersection is from 0 to 3. That's the boundary of the area. Okay, that's so we have 0 to 3. So I think what's nice here in the second half of the semester that you can now use your formula. So if you observe your alpha button, so below the alpha button is you have this button marginane ang dagway. Okay, so you can now use that portion, and ang magawas ana is ani siya ang magawas dx. So plug in your equation in the first box. So you need to use alpha x. So make sure that you don't have any value for alpha x. And there's no stored number in your letters. Okay, so if we're going to solve that one, so 3x minus x squared from 0 to 3. So the answer is 9 all over 2 square units. So square units because we are solving the area. Okay, so that's for the vertical strip. So if you're going to use the horizontal strip, so that's the same concept, but our strip is now in the horizontal direction. So the same concept as the vertical strip. So it should be that if we place it anywhere in the bounded region, so the x right and the x left equations are consistent. So x right here is the red graph. So as you can see, that's very consistent. And then the x left graph in your equation is the blue one. So since we are going to use it in terms of y now, so notice that the red graph is y equals to x squared. So para mahimo siyang in terms of x function, so y is equal to x squared, and then we're going to isolate x, so we have to get the square root. So x equals square root of y. So this one are the same. So one is in terms of y, one is in terms of x. So for the other equation, the equation of the line, so y is equal to 3x, and then isolating your x parameter, so that will be x equals y all over 3. So again, these two equations are the same, but one is in terms of x, so y is equal to x something, and the other one is in terms of y, x equals y something. So muna siya ang difference in expressing it in terms of x or in terms of y function. So let's try to observe the difference. So in horizontal strip, the formula is y top y1 to y2, and then x right minus x left dy. So again, our x right is the red graph. That's the parabola, y equals to x squared. So this one is now our x right. Kay ganina, this one is the y bottom. This one is the y top. So this one is the x left in the horizontal strip. Okay, so this time is, since we are now in the horizontal strip, so everything should be in terms of y. So going back to the points of intersection, so we now have 0 and then 0. So also in the points of intersection, so that's verified. So 0 and 0. So 0 and from y1. And then going to the second boundary, that's 9. Okay, so 9. So from 0 to 9. So x right is square root of y, and then minus x left is y all over 3 dy. So if you're going to use your calculator, so let's hope that the answer is the same. So if you're going to use your calculator, so instead of y, so just use x first. So instead of alpha y, just use alpha x, because the the default integral, or if the default variable for the calculator is x. As you notice, if you click the definite integral button, so that's always dx here. So dx should ang magawas. So from 0 to 9. So the answer, so So if you notice that if you're using your calculator right now, so it's taking a lot of time getting the answer compared with using the vertical strip. So karon wa pay answer ang calculator, so I think it's 9 halves gapon siya. Okay, so the difference is the way the calculator behaves or the way the calculator is solving the equation, because in the horizontal strip you are now dealing with a radical expression. Yan, napadyoy fraction, di ba? So ang igawa sa calculator is 4.5. So that's 9 halves still, di ba? So karon pa nigawa sa answer sa calculator. So again, if you notice that the difference between the two strips is that the vertical strip, if you're going to look at the equation, it's a simple equation and the calculator can easily solve this one. That's why in a matter of seconds, you'll already get the answer. But for this equation, since you are dealing with a square root function, so it's taking a lot of time giving us the answer. So the advantage is, I think you're going to observe your equations, whether you're going to use the vertical strip or the horizontal strip in your solution. So that's the difference. So one strip is going to give you the easy integrand. The other strip will give you the complicated version of your integrand. And again, if you're going to use the calculator, so the better one should be the easier equation. So of course you need to help your calculator a bit so that it gives you the answer immediately. Alright, so I think that's for problem number 1. So what's important here is you need to know how to graph your equations. And then second one is you need to determine your points of intersection. So whatever technique you have there, whether you're going to use tables or you're going to equate your equations to get the points of intersection. And then lastly is you're going to use a vertical strip or the horizontal strip in your solution. And again, in determining your vertical or horizontal strip, so of course, you need to label your graph as well. All right. So do you have questions or clarifications? So taas na kayo, no? One problem pa ta. Okay, so this is the solution for the vertical strip. And then this one is the solution for the horizontal strip. So both vertical and horizontal strip will give you the same answer. This one and then the other one is also the same. Okay, so let's try to solve problem number 2. So again, as for problem number 1, just review it in the recording later. Okay, so for the second figure, so again, the first step will always be to graph your equation. Nagbati man. So you need to graph your equation. Okay, so the technique here is you need to solve first the points of intersection. So we have y equals x to the power of 4. Then the other one is y equals 2x minus x squared. Okay, so equating the two equations, so you now have x to the power of 4 is equal to 2x minus x squared. And then grouping together your equations, so you now have x to the power of 4 plus x squared, and then minus 2x is equal to 0. And then getting one x variable, so you now have x times x cubed plus x minus 2 equals 0. So the first value of x that we have is x equals 0. So how about for the trinomial or the third degree equation inside the parenthesis? So if you're going to discover the potential of your calculator, so you can go to mode 5. So that's mode, and then press 5. Then so 5 is the equation. Ang magawas niya is 5 and then equation. So for other calculators, just find the equation portion in your calculator that you are using. So if you're not using Casio, so just explore the functions of your calculator as long as it's under the mode button. So mode and then find the equation category. So once you press 5, so there will be 4 equations that will be presented in the screen. So go to number 4. So mode 5 4, because 5 is equation, and then the fourth one is ax cubed plus bx squared plus cx plus d is equal to 0. So once you press 4, so you're asked to input the coefficients of the x variables a, b, c, and d. So since we are following the format given by the calculator, so you also need to follow or input the necessary details according to the format that the calculator has given. So for example, in this equation, so the coefficient of x cubed a is 1, x squared, so we don't have any x squared, so this one is 0. Coefficient of x here, cx is 1. Then our d is, so since this one is positive d, this one is negative 2. So our d is negative 2. So 1, so upon inputting the values, so starting with a, so 1 equals sign, 0 equals sign, and then 1 equals sign, then negative 2 equals sign. So once you're done inputting the different coefficients per box, so equal sign again, then you're given, so x1 is 1, and then x2 is an imaginary number, so imaginary, then x3 is also imaginary number. Okay, so let's try to graph x equals 0 and then x equals 1. So x equals 0, so negative imaginary, so we won't be utilizing the imaginary numbers. So at x equals 0, so y equals 0 to the power of 4. So y is also 0, di ba? So meaning the first point of intersection is at 0, 0. So this one is the first point of intersection between the two curves. Y is equal to x to the power of 4, then y equals 2x minus x squared. Okay, so next is at x equals 1. So y equals 1 to the power of 4. So y is equal to 1. So the next point of intersection is at 1 and 1. So this is 1 and 1. So let's try to make it bigger lang guys, since we have a small limits of integration. So let's say this one is our 1. So this one is 1, 1, and then this one is 0, 0. So graphing the two equations, so starting off with y equals to x to the power of 4. So the technique here is we're going to have this portion here, so the origin is always 0. Then the linear part is where the curve is heading. So upward siya, upward ana. Tarong muna. Okay. And then for the second portion, so if you know your concepts from your analytic geometry, so this one is 0, and then this one is so this one is 0, and then if we're going to use this in basic terms, excuse me. So this will be negative, and then x squared minus 2x. Then if you want to complete the square, you need to determine the standard formula of your parabola. So if you don't know the standard formula, so try to research it na lang para you won't have madugay. Okay, basta ang yang graph ani, so let's try to So this one is y equals to x to the power 4. Then we're going to use another color. Okay, so in the second graph, so this is the behavior of the second graph. Oops, sorry. So it's pointing downwards. So this is y equals 2x minus x squared. So why it's pointing downwards? Because the vertex of this parabola is at 0 and 1. Siya 0 and 1 and 1 day. So you'll determine the vertex if you know how to make this one in standard form. Sama na siya ang drawing. So next is you're going to again determining if you're going to use a vertical strip or horizontal strip. So as what I have discussed in the previous number, so if you're going to choose the vertical strip, so it should be that if I place the vertical strip at the bottom portion, so it is the same as the other portions as well. So what do I mean by this is that the top portion is touching the same graph. So notice that the top portion of the strips is touching the blue graph, and then the bottom part of each strip is touching the green graph. Okay, so this is y bottom, this is y top. So using the vertical strip, so the area is equal to, so this is x1 to x2, and then y top minus y bottom dx. So again, since we are in the x parameter, so from x1 to x2, that is from 0 to 1. Then y top is the blue graph, that's 2x minus x squared. So 2x minus x squared. And then minus y bottom, that's x to the power of 4. That's the green graph. And then dx. So again, you can now use your calculator. So just to go back to the original setting, so just use shift clear and then the alls, yeah, no, shift clear and then 3 for those using 991 ES plus. So again, the bottom, the button for the definite integral is this one. That's below the alpha button. So if you're going to plug in the equations, so make sure that everything is in terms of x. So alpha x and 2 alpha x minus 2 minus alpha x squared, and then you have to make sure also that you're using the correct usage of your parentheses. so that the calculator won't get confused. Okay, so the answer is 7 over 15 square units. Yes, that's 7 over 15. Okay, so if you're going to use the horizontal strip as well, so let's try using the horizontal strip. So again, it should be consistent. So the right portion is touching the same graph. So whatever placement of the horizontal strip you're going to do. So notice that the right portion is always touching the green graph, and then the left portion is always touching the blue graph. So this is your x right, and then this one is your x left. So the difference is, so we need to make it in terms of x equals y something. So this one becomes x equals the fourth root of y. And then notice that in the second figure, I mean in the second equation, so it's difficult for us to convert this one into in terms of x because we have two variables of x, diba? So bisag kung saan pa siya bali-bali, so we cannot achieve, we can achieve the y portion of this one, but we still need to do some completing the square process. So let's try. So we have x squared minus 2x, and then you have negative y. So completing the square is you have 2x plus 1, then negative y plus 1. So this becomes x minus 1 squared. Then this one is negative y plus 1. So again, notice that this one is the origin. The vertex 1, 1. So we now have x minus 1, then we have the square root of 1 minus y, and then x equals square root of 1 minus y plus 1. So this one is our x, I think this one is x left, and then this one is x right. So if you're going to use the horizontal strip this time, so that will be from y1 to y2, and then x left minus x right dy. So from 0 to 1, so baliday, x right minus x left. So x right is the green graph, so that will be the fourth root of y minus the square root of 1 minus y plus 1 dy. So notice that if you're going to use your calculator, So let's try the fourth root of y. So again, if you're going to plug this one in the calculator, so it should be in terms of x because the default function of your calculator is always with respect to the x variable. Then square root of 1 minus and plus 1. So this one is plus 1. And from 0 to 1. So notice that the calculator is having a hard time integrating because it is integrating a difficult equation. So if you compare the integrand of the vertical strip and then the integrand of the horizontal strip, so without the calculator, so as a person, so it's easier to integrate this equation, diba? Compared having the radical expression. So that's why when you solve the problems later, so it's better that you're going to observe which strip is better to use in this particular problem because you also need to help your calculator a bit in getting the answer quickly. Ba? So murag karon wa pa siya answer. So let's hope that the answer is 7 over 15 square units. So as of the moment, my calculator is still loading. So wala siya. So for those of you who didn't understand what I just said, so kani siyang given equation, these are y in terms of x. And then x right and x left, so that will be x in terms of y. X equals y something. Diba? So as you notice here, the y top became the x variables. The y function bottom becomes the x variable also. So same goes for your x right and x left. Okay, so since wala man siya response, so I think that's